हेलो गाइस, वेलकम टू द न्यू वीडियो। तो पिछले वीडियो में बात किए थे मॉडल रिप्रेजेंटेशन के बारे में एंड नाउ दिस वीडियो में वी गोना टॉक अबाउट कॉस्ट फंक्शन डिक्लेरेशन। कैसे हम कॉस्ट फंक्शन को डिक्लेयर करेंगे या फिर कौन सा कॉस्ट फंक्शन यूज करेंगे। सो वी विल सी ओवर हियर। ओके, सो पिछला वीडियो में हमको क्या मिला था, जो हाइपोथेसिस है h और वी कैन कॉल इस h थीटा ऑफ x, वी कैन राइट दिस वी गॉट व्हाट थीटा 0 प्लस थीटा 1 x1। ओके, दिस वाज आवर मॉडल and we gonna use this model to create the cost function। ठीक है, so suppose cost function एक्चुअली है क्या। cost function से पहले हम जानेंगे द एरर। किसी भी मॉडल में एरर क्या होता है। ठीक है, हम तो मॉडल को ऐसे लिख दिए। सपोज हम मॉडल को हम डिक्लेयर करेंगे ऐसे। सपोज here these are training set we have and these are the datas like we can call it x1 x2 x3 x4 and apparently this is y1 y2 y3 y4. As you know, this is the input, this is called the input and this is the output। okay, so now अगर जब ये h थीटा ऑफ x, इसका जब थीटा 0 एंड थीटा 1, पहले क्या होगा, पहले तो ये मॉडिफाई नहीं होगा। ये h थीटा ऑफ, या फिर वी कैन सी फॉर द स्ट्रेट लाइन y इक्वल्स टू mx प्लस c। क्या होता था इसके लिए, इसके अंदर क्या होता था, जो स्ट्रेट लाइन होता था ना, स्ट्रेट लाइन का वैल्यू क्या होता है, m और c के ऊपर डिपेंड करता है। जस्ट लाइक दिस, यहाँ पे जो मॉडल होगा, वी क्रिएट दिस मॉडल लाइक दिस फॉर द फर्स्ट केस। सपोज फॉर द फर्स्ट टाइम द मॉडल विल लुकिंग लाइक दिस। ओके, सो द मॉडल इज डिपेंडिंग अपॉन व्हाट, थीटा 0 एंड थीटा 1। ओके, इसके ऊपर डिपेंड किया हुआ है। तो which each iteration we gonna update the theta 0 and theta 1, we can modify the theta 0 and theta 1 so that we can get the optimal model like this। Suppose for this if we create this and this will be the optimum model। Okay, we can see this will be the optimum model। so now for this case, so how can you get the optimum model, or like this, how can you get it? So it's very simple to get the optimal model। we have to find the error between it and then we gonna ask what is error। so error क्या होता है, error होता है हमारे पास। suppose for this is we can write this is the actual y बा actual output हम कह सकते हैं। ठीक है, according to this x2 input। but if we say that for this x2, अगर हम ये x2 अगर इस मॉडल के ऊपर दिस मॉडल के ऊपर हम इनपुट करें तो हमको भी एक आउटपुट मिलेगा, दैट इज कॉल्ड द प्रेडिक्टेड आउटपुट। ठीक है, सो दिस इज द प्रेडिक्टेड आउटपुट फ्रॉम दिस x2 के अंदर इधर यहाँ पे प्रेडिक्टेड आउटपुट और भी y hat whatever it call we can call this। so for this there is a difference between this and this, so the distance for this case, the distance between this and this will be called the error। for this case this is the x2 and we can call it e2। okay, and we can see, as we can see for this case this is x1 x2 x3 x4। हम देख सकते हैं कि यहाँ पे x2 का जो प्रेडिक्टेड मॉडल होगा y hat सॉरी, सो दिस विल बी लेस देन e2। ठीक है, मतलब दिस इज लेस देन दिस मॉडल, मतलब बिफोर जो होता है, जो बिफोर जहाँ पे था, ये इस मॉडल यहाँ का जो एरर है वो इससे बहुत ज्यादा है। तो दिस इज अपेरेंटली लेस देन दिस एरर, so this is more optimized and the model depend on what, the theta 0 and theta 1। this is more optimized model, that is their parameters, that is theta 0 and theta 1 is more optimized। okay, as simple as that। so we have to calculate the error and minimize the error। so how we gonna do this, suppose, and first how we gonna calculate the error। ठीक है, for first suppose for e2, okay, for e2 we can calculate the error, that is y hat, or we can call this the h theta of x। so we can see that error between these 2 points are h theta of x 2 and y2, this is the error between this and this। okay, and for this case this is also same, therefore e2 equals to h theta of x2 minus y2। but from this image we can see the error is less for here, so this is, for this case the error is high। okay, so we have to calculate for each and every data point। okay, we have to calculate the total error। so if you calculate the total error, then the total error will be looking like this। so then we do total error। okay, the total error will be looking nice for each cases। here we have 4 data points, so that will be e1 plus e2 plus e3 plus e4, only 4 data points। so if we generalize this form, we can write like this, that is the summation of I equals to 1 to 4 e to the power I। okay, we can write this। so for these 4 points we get the error like this। okay, we get the error like this। but in some cases we can see that the जो ये error होता है ना, ये कभी कभार, मतलब अगर y2 का वैल्यू ज्यादा हो h theta of x से, so then क्या होगा, तो ये नेगेटिव आ जाएगा, एंड डिस्टेंस कैन नेवर बी नेगेटिव. सो व्हाट वी डू, we just square this thing. We just simply square this thing to get over the minus problem. And this is called the square error. This is called the square error. Okay. So we'll see this. Okay, later here over here. So this is only for only 4 points, 4 data points. Okay. But generalize for m number of point. What will be the error? The error will be summation over I equals to 1 to m, okay, e to the power I. Okay, so here what is e to the power I? We can write e to the power I like summation of I equals to 1 to m h theta of xi minus yi, as simple as that. And as we see, we are using the square error, we can square the thing. So this is the total error. Okay, so now we need to more optimize the theta. Okay, for this case we can calculate the error, we can optimize the theta, but if you want to more optimize it properly, so we have to add some few stuff in it. So suppose if we add one single 1 by m over here, then this thing will be called the mean square error. Okay, and this is more efficient than square error. For y equals to m h theta of x of I minus y of I. This is the mean square error. So that we can, now we can write like this: the mean square error, the MSE equals to 1 by m summation over I equals to 1 to m h theta of x minus xi. H theta of xi minus yi. Okay, whole square. We have the mean square over here. So now for the further simplification, we can add simple 1 by 2 over here. Okay, 1 by 2 over here, and the rest of the things will be same. That is I equals to 1 to m h theta of xi minus yi and its whole square. Okay, so in case of 1 by 2, it does not change the optimal value of the theta. Okay, so we will call it the cost function. Okay, this is the cost function. We just created the cost function from the error. So this is called the mean square error cost function. Okay, we can say this. So this is the cost function. So here j represent the cost function. J represent the cost function. Okay, cost function. Now our objective is what? Our objective is to minimize j. As we know before, that our objective is minimize j to get what? To get the optimal value of the parameters theta 0 and theta 1, because if we modify and if we optimize these two parameters, then we'll have our optimized model. Okay, so if we write like this, if the hypothesis is this, hypothesis is h theta of x equals to theta 0 plus theta 1x. Okay, and the parameters are theta 0 and theta 1, and the cost function is what? Now we have the cost function, so the cost function is j of, according to theta 0 and theta 1, 1 by 2m summation over I equals to 1 to m h theta of xi minus yi. Okay, and our goal is what? This is the goal. The goal is to minimize j, theta 0 and theta 1, minimize the cost function according to what? Theta 0 and theta 1. With respect to theta 0, with respect to theta 0 and theta 1, we have to minimize this cost function. This is our goal.